Good morning, my dear students. Welcome to my channel Desire to Learn with Mukesh. So, today in this video, we are going to discuss the question answers, various question answers from the second chapter of class 9th science, that is matter around us pure? In the previous video, we have discussed the summary of the lesson in the form of PPT. If you have not watched the video, then you can go to the description and you can watch the video. Then here in this video, we are going to discuss three types of question answers. First is your in-text question answers that are being provided in the lesson. Then after that, we will discuss exercise question answers which are given after the ending of the lesson. Then after we will discuss self-created question answers that I have created for you for more practice. So first of all, without being late, now we are going to start in-text question answers. First question is, what is meant by a pure substance? So all of you know a substance having single type of particles is known as a pure substance. For example, hydrogen, water, etc. are pure. All elements and compounds are considered to be pure. Second question is, list the points of differences between homogeneous and heterogeneous mixtures. So a mixture which has a uniform composition throughout is called a homogeneous mixture. These are called solutions also. And in case of heterogeneous mixture, a mixture which contains physically distinct parts and have non-uniform composition. That means the ratio of the components in different parts of the mixture are different. That is called your heterogeneous mixture. In case of homogeneous mixture, the ratio of the components is same at every point of the mixture. Second, in case of homogeneous mixture, its constituent particles cannot be seen easily. But in case of heterogeneous mixture, its constituent particles can be seen easily. Then, in case of homogeneous mixture, there are no visible boundaries of separation in a homogeneous mixture because the particles are intermixed properly. And in case of heterogeneous mixture, they have visible boundaries of separation between the constituents because here the particles are not intermixed properly. Then, in case of homogeneous mixtures, its constituents cannot be easily separated, but the constituents in heterogeneous mixture can be separated by simple methods. And examples of homogeneous mixture are LOS, salt dissolved in water, sugar dissolved in water. These are also called solutions. And example of heterogeneous mixture are mixture of sand and common salt, mixture of sand and water, oil and water. These are the examples of heterogeneous mixtures. Now, how are solution and suspension different from each other? So we have to draw a comparison among the three: solution and suspension. First, solution or true solution. Solution or true solution is homogeneous, but sol or colloidal solution is heterogeneous and suspension is also heterogeneous. In case of solution or true solution, there is no Tyndall effect. But in case of sol or colloidal solution, there is Tyndall effect. And in case of suspension, also there is a Tyndall effect. In case of solution, solute particles cannot be filtered by using a filter paper. In case of colloidal solution, cannot be separated by ordinary filter paper also. Then in case of suspension, it may be transparent or translucent. Then is in case of true solution, the true solution is transparent. But in case of colloidal solution, it may be transparent or translucent. In case of suspension, it can be separated easily by filter paper and it is transparent or translucent. It may be transparent or translucent. Then examples of true solution are seawater, LS, solution of lemon juice. These are the examples of true solution, or we call them solution. And examples of salt or colloidal solution are milk of magnesia, cough syrup, mist, fog, clouds, smoke, mud. These are the examples of colloidal solution. Next is suspension. Example of suspensions are mixture of sand in water, mixture of chalk in water. These are the examples of suspension. Now, there is a mathematical question. To make a saturated solution, 36 gram of sodium chloride is dissolved in 100 gram of water at 293 Kelvin. Find its concentration at this temperature. So, here you can see mass of sodium chloride is 36 gram and mass of water is 100 gram. Here, sodium chloride is the solute and water is the solvent. We know that mass of solution equal to mass of solute plus mass of solvent. So 36 gram plus 100 gram equal to 136 gram. Then concentration, mass percentage of the solution equal to, the formula mass of solute by mass of solution multiplied by 100. So 36 gram by 136 gram multiplied by 100. So it will be 26.47 percentage. Now, how will you separate a mixture containing kerosene and petrol? Difference in their boiling points is more than 25 degrees Celsius, which are miscible with each other. So, here simple distillation is the method which can separate the mixture of kerosene and petrol where boiling point differ by more than 25 degrees Celsius. Method is, in a distillation flask, a mixture of kerosene and petrol is to be taken. The mixture is to be heated slowly and the temperature is to be recorded with the help of thermometer. Petrol boiling point 70 degrees Celsius to 1200 degrees Celsius vaporizes fast and the temperature becomes constant for some time till all petrol evaporates from the mixture. Vapors of petrol are to be condensed and collected in another container while the kerosene remains in the distillation flask. As soon as the temperature starts rising again, the heating is to be stopped and both the components are to be collected separately. Now, name the technique to separate butter from curd, salt from seawater, camphor from salt. So, by using centrifugation method, we can separate butter from curd. And by using evaporation method, we can separate salt from seawater. And by using sublimation method, we can separate camphor from salt. What types of mixtures are separated by the technique of crystallization? Crystallization method can be used for the purification of those mixtures which contain insoluble and or soluble impurities. Those have crystalline nature. Those cannot be separated by filtration as some impurities are soluble. So here only we have to follow the method of crystallization because here you will get the solute in the form of crystal. So that method is called as crystallization method. Next, classify the following as chemical or physical changes. So here are some changes given. We have to classify them into chemical or physical changes. Cutting of trees, melting of butter in a pan, roasting of almira, boiling of water to form steam, passing of electric current through water, and the water is breaking down into hydrogen and oxygen gases, dissolving common salt in water, making a fruit salad with raw fruits, and burning of paper and wood. So if we will categorize them into physical and chemical changes, then physical changes will be cutting of trees, melting of butter in a pan, boiling of water to form steam, dissolving common salt in water, making a fruit salad with raw fruit. These are the examples of physical change. And the chemical changes are roasting of almira, passing of electric current through water and the water breaking down into hydrogen and oxygen gases, then burning of paper and wood. These are the examples of chemical changes. Now, try segregating the things around us as pure substance or mixture. So, wood is your mixture and coal is your mixture. Milk is also mixture. Sugar is pure substance. This is a compound. Then common salt is also a compound, a pure substance. Then soap can be a compound or mixture. Then soil is a mixture and rubber is a pure substance. Wood is not a pure substance but a homogeneous mixture because it is composed of compounds such as cellulose, hemicellulose, and lignin, which are made up of elements such as carbon, hydrogen, and oxygen. In biology, you will read about these materials. Then, coal is a heterogeneous mixture of carbon, hydrogen, sulfur, volatile impurities, and moisture. Milk is a mixture of water, milk, protein, and fat. Soap is a mixture of sodium and potassium salts of long chain fatty acids containing of carbon atoms. Soap is also considered as an organic compound which is made up of fatty acid and glycerols. So soap can be a mixture or can be a what we call compound. Now we'll come to exercise question answers. So first question is, which separation techniques will we apply for the separation of the following? Sodium chloride from its solution in water, ammonium chloride from a mixture containing sodium chloride and ammonium chloride, small pieces of metal in the engine of oil of a car. Then different pigments from an extract of flower petals, butter from curd, oil from water, tea leaves from tea, iron pins from sand, wheat grains from husk, fine mud particles suspended in water. So first of all, sodium chloride from its solution in water. So for this to separate, we can use evaporation method. If you will evaporate, then water will evaporate and sodium chloride will be there. Then ammonium chloride from a mixture containing sodium chloride and ammonium chloride. For this we can use sublimation method because here ammonium chloride is a volatile substance. Then small pieces of metal in the engine oil of a car. Here we have to follow filtration method. We have to filtrate. Then different pigments from an extract of flower petals. Here we have to follow chromatography. Butter from curd. Here we have to follow centrifugal machine or churning the curd by hand. We can churn the curd by our hand or we can use centrifugal machine. So we have to simply follow here centrifugation, right? Then oil from water. For separating oil from water, we have to follow decantation method. To separate oil from water, we have to follow decantation method, or we can, yes, by using a separating funnel, we can separate them. Then tea leaves from tea. Here we have to follow filtration method. Then iron pins from sand, we have to follow magnetic separation. We can use a magnet to separate the iron pins from sand. Then wheat grains from husk, here we have to follow winnowing method. And fine mud particles suspended in water, we have to follow here coagulation and decantation method. Then write the steps you would use for making tea. Use the word solution, solvent, solute, dissolve, soluble, insoluble, filtrate, and residue. So methods of preparation of tea is, first we have to take some water, that is solvent, in a pan and heat it. Add some sugar, that is solute, and boil to dissolve the sugar completely. The obtained homogeneous mixture is called solution. Add tea leaves or tea powder in the solution and boil the mixture. Then after, now add milk and boil again. Filter the mixture through the tea strainer and collect the filtrate or soluble substances, that is tea in a cup. The insoluble tea leaves left behind as residue. So in this method we can we can make tea. Now Pragyan tested the solubility of three different substances at different temperatures and collected the data as given below. Results are given in the following table as grams of substance dissolved in 100 grams of water to form a saturated solution. Here you can see substances dissolved, temperature in Kelvin, solubility. So, what mass of potassium nitrate would be needed to produce a saturated solution of potassium nitrate in 50 gram of water at 313 Kelvin? Here you can see from the table, mass of potassium nitrate needed to produce its saturated solution in 100 gram of water at 313 Kelvin is equal to 62. Okay, 62 gram. Mass of potassium nitrate needed to produce its saturated solution in 50 gram of water. Here, the amount of solvent became half. So here we have to also make the quantity of what we call potassium nitrate half. So it will be 31 gram. Next. Next question is your Pragya makes a saturated solution of potassium chloride in water at 353 Kelvin and leaves the solution to cool at room temperature. What would she observe as the solution cools? So, here crystals of potassium chloride are formed. This happens as solubility of solid decreases with decreasing the temperature. If you decrease the temperature, then solubility also decreases. So, crystals of potassium chloride will be formed here. Then find the solubility of each salt at 293 Kelvin. Which salt has the highest solubility at this temperature? From the table, you can simply find out solubility of a solid is that amount in gram which can be dissolved in 100 gram of water, that is solvent, to make saturated solution at a particular temperature. So solubility of each salt at 293 Kelvin, you can find out from the table directly. That is a potassium nitrate 32 gram per 100 gram water, sodium chloride 36 gram per 100 gram water, potassium chloride is 35 gram per 100 gram water, and ammonium chloride 37 gram per 100 gram of water. From the table you can directly find the answers. Then ammonium chloride has the maximum solubility. You can see here ammonium chloride has the maximum solubility, that is 37 gram per 100 gram of water at 293 Kelvin. At 293 Kelvin you can find here easily from the table directly. Okay, next question number D is, what is the effect of change of temperature on the solubility of a salt? So here solubility of a solid salt decreases with a decrease in temperature while it increases with a rise in temperature. If you increase the temperature, then solubility also will increase, and if you decrease the temperature, then solubility also will decrease. You know, in the PPT discussion, we have discussed that if a saturated solution will be heated, then it will become a super saturated solution. That means it will gain the ability to dissolve more solute. That is called super saturated solution. So if you increase the temperature, then the solubility will also increase. If you decrease the temperature, then solubility also will decrease. Then explain the following giving examples. First is saturated solution. Saturated solution is a solution in which no more amount of solute can be dissolved at a particular temperature. Is called saturated solution. And what is pure substance? Already we have discussed it many times. A substance made up of single type of particles, that is atoms or molecules, is called pure substance. In case of elements, it is atoms. In case of compound, it is molecules. All elements and compounds are said to be pure. For example, water, sugar. So here example of saturated solution also given. When sugar is dissolved repeatedly in a given amount of water, a condition is reached at which further dissolution of sugar is not possible in that amount of water at room temperature. That at that time the solution will become saturated. But if you heat the saturated solution, then it will become super saturated and it will gain the ability to dissolve more solute. Then colloid, a heterogeneous mixture in which the solute particle size is too small to be seen with the naked eye but is big enough to scatter light is known as colloid. There are two phases in colloidal solution. Dispersed phase, solute particles are said to be dispersed phase, and dispersion medium. The medium in which solute particles are spread is called the dispersion medium. For example, milk, clouds. These are the examples of colloid. Milk is the best example. Then suspension. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of suspension are visible to the naked eye. For example, mixture of sand, water and muddy water. These are the examples of suspension. Then classify each of the following as a homogeneous or heterogeneous mixture. Soda water, wood, air, soil, vinegar, filtered tea. Here, homogeneous mixtures are air, soda water, vinegar, and filtered tea. And heterogeneous mixtures are wood and soil. Homogeneous mixture means in every part of the mixture, the ratio of the components is same. Heterogeneous mixture means in different parts of the mixture, the ratio of the components are different. Then how would you confirm that a colorless liquid given to you is pure water? If the given colorless liquid boils at 100 degrees Celsius, then it is pure water because you know the boiling point of water is 100 degrees Celsius. Which of the following materials fall in the category of a pure substance? Ice, milk, iron, hydrochloric acid, calcium oxide, mercury, brick, wood, air. You know, pure substances are either elements or compounds. So, ice, iron, calcium oxide, mercury are pure substances as they have definite composition. Milk is a colloid, so it is a homogeneous mixture. Hydrochloric acid is also a mixture of hydrogen, fluid, gas, and water. Brick and wood are also mixtures. Now, identify the solutions among the following mixtures: soil, seawater, air, coal, soda water. Seawater, air, and soda water are homogeneous mixture. Coal and soil are heterogeneous mixture. Which of the following will show Tyndall effect? You know, colloidal solutions show Tyndall effect. So here, milk and starch solution will show Tyndall effect, as both of them are colloidals. Next, classify the following into elements, compounds, and mixtures: sodium, soil, sugar solution, silver, calcium carbonate, tin, silicon, coal, air, soap, methane, carbon dioxide, blood. Here elements are sodium, silver, tin, and silicon. Compounds are calcium carbonate, methane, and carbon dioxide. Mixtures are soil, sugar solution, coal, air, soap, and blood. Which of the following are chemical changes? Growth of a plant, roasting of iron, mixture of iron fillings and sand, then cooking of food, digestion of food, freezing of water, burning of a candle. You know, chemical changes are those changes in which new substances are formed or the chemical composition changes. So the chemical changes will be here: growth of a plant, roasting of iron, cooking of food, digestion of food, burning of a candle. These are chemical changes because here chemical composition of substances changes and here new substances are formed. Now we will discuss some self-prepared question answers that I prepared for you for more practice. So first of all, fill in the blanks. Alloy is a solid solution while dash is a gaseous solution. You know, air is a gaseous solution. A solution of iodine in alcohol is known as tincture of iodine. A special technique of separation known as dash can be used to separate the colloidal particles. This is your centrifugation. Separation of dyes in black ink can be done by using chromatography. Chroma in Greek means color. Separation of two miscible liquids can be done by distillation. The crystallization method is used to purify solids. The number of yes, in this method, in crystallization method, we will get the crystals of solids. That's why the method is called crystallization method. The number of elements known at present are more than 100. There are dash naturally occurring elements, 92 natural occurring elements. two elements, mercury and dash, are liquid at room temperature. Mercury and bromine. Elements gallium and dash become liquid at temperature slightly above room temperature, that is 303 Kelvin. It is your cesium, gallium and cesium. When we heat a mixture of iron and sulfur powder, dash is evolved. Here hydrogen sulfide will be evolved. Hydrogen sulfide smells like rotten eggs. A device used to separate liquids from solids by spinning is called your centrifuge. Now we will discuss some more question answers. First of all, what are mixtures? Mixtures are constituted by more than one kind of pure form of matter. A mixture contains more than one pure substance. Then what is solution? What are the properties of a solution? A solution is a homogeneous mixture of two or more substances. Example, lemonade, soda water. These are the examples of mixture. Solution. Then properties of a solution are: a solution is a homogeneous mixture. The particles of a solution are smaller than 1 nanometer, that is 10 to the power minus 9 meter in diameter. So they cannot be seen by naked eyes. Because of very small particle size, they do not scatter a beam of light passing through the solution. So the path of light is not visible in a solution. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed. So solution is stable. Then what is an alloy? Why do an alloy is considered as a mixture? An alloy is a mixture of two or more metals or a metal and a non-metal. It cannot be separated into their components by physical methods. Example, brass is an alloy of 30% zinc and 70% copper. An alloy is considered as a mixture because it shows the properties of its constituents and can have variable composition. Mixtures have variable composition and they show the properties of all of their components, all of their constituents or components. So here alloy is also a mixture because it shows the properties of all the constituents and have variable composition. What is yes, compound have what do you call standard composition, but mixtures don't have standard composition, they have variable composition. Then what is solute and what is solvent? Give example. Solvent is the component of the solution that dissolves the other component in it, and it is present in larger amount in a solution. And solute is the component of the solution that is dissolved in the solvent and it is present in lesser quantity in a solution. For example, in the solution of sugar and water, water is solvent and sugar is a solute. Like that, in the solution of salt and water also, salt is the solute and water is the solvent. Usually we take the solvent in more quantity and we take the solute in less quantity. Then what is saturated, dilute and concentrated solution? At any particular temperature, a solution that has dissolved as much solute it is capable of dissolving, it is said to be a saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. If the amount of solute contained in a solution is less than the saturation level, then it is called unsaturated solution. A dilute solution is one in which there is a relatively small amount of solute dissolved in the solution. And super saturated solution is that when we heat a saturated solution, then the solvent will gain the ability to dissolve more solute. At that time, the solution will become super saturated. Then what is solubility of a solution? Solubility is defined as the maximum amount of substance that will dissolve in a given amount of solvent at a specified temperature. Then what is concentration of a solution and how can we find it? And here is a mathematical sum. A solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. So first we will define the concentration of a solution. So the concentration of a solution is the amount of solute present in a given amount of solution. So here, there are different ways to express the concentration of a solution. Some of them are like this: mass by mass percentage of a solution is equal to mass of solute by mass of solution multiplied by 100. Mass by volume percentage of a solution is equal to mass of a solute by volume of a solution multiplied by 100. And volume by volume percentage of a solution is equal to volume of solute by volume of solution multiplied by 100. Now we will solve the sum. So here mass of solute was given, that is mass of salt, that is 40 gram, and mass of solvent, that is of water, was given 320 gram. Mass of solution will be mass of solute plus mass of solvent. So 40 gram plus 320 gram it equal to be 360 gram. Now mass percentage of solution equal to mass of solute by mass of solution multiplied by 100. So 40 by 360 multiplied by 100. So it will give 11.11%. Now what is suspension? Write the properties of a suspension. So first of all, what is suspension? A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Properties of a suspension are: suspension is a heterogeneous mixture. The particles of a suspension scatter a beam of light passing through it and make its path visible. Then the particles of a suspension can be seen by the naked eye. The solute particles settle down when a suspension is left undisturbed. So suspension is unstable. They can be separated from the mixture by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. So when the particles settle down, then the suspension will break and it will not scatter light anymore. Now, what is colloid? Write its properties. A colloid solution is a heterogeneous mixture in which particles are uniformly spread throughout the solution. For example, milk, mud, butter. These are the examples of colloid. Now, properties of a colloid. A colloid is also a heterogeneous mixture like the suspension, and the size of particles of a colloid is too small to be individually seen by naked eye. Colloids are big enough to scatter a beam of light passing through it, and make its path visible. And the property of a colloid that scattered the beam of light is called your Tyndall effect. They do not settle down when left undisturbed, so that is, a colloid is quite stable. They cannot be separated from the mixture by the process of filtration, but a special technique of separation known as centrifugation can be used to separate the colloidal particles. So we cannot separate the particles of colloid by the method of filtration, like in case of suspension. We have to use centrifugation method to separate the colloidal particles. Now, what is Tyndall effect? This is very important. So the phenomenon of scattering of a beam of light by colloidal particles when passed through a colloidal solution is called the Tyndall effect. So when you pass a beam of light through the colloidal solution, the particles of colloidal solution will scatter the beam of light, and that is called the Tyndall effect. When light is passed through a colloidal solution, it is observed that the colloidal particles do not permit the light to pass through it completely. They will scatter it. That is called the Tyndall effect. Here you can see in the picture demonstration of Tyndall effect. When you pass a beam of light from a torch through copper sulfate solution, copper sulfate solution is true solution, so light is invisible here because it will not scatter. But in case of milk is a colloid, so here it will be light visible because it will scatter the beam of light. And in case of milk, you will find Tyndall effect. That is called Tyndall effect. But in case of copper sulfate, you will not find Tyndall effect. Tyndall effect means the property of scattering the beam of light. When you pass a beam of light through the colloidal solution, the particles of colloidal solution will scatter the beam of light. That is called Tyndall effect. Okay. Then Tyndall effect also can be observed when a beam of light enters a room through a small hole. You can see, and scattering of beam of light occurs by the particles of dust and smoke in air. Because in air there is dust and smoke, so they act like the particles of colloid. Then, when sunlight passes through the canopy of a dense forest, you can see, because there are small water droplets in the fog of the forest, so they will also act like colloidal particles and they will scatter the beam of light. That is also called Tyndall effect. Now, write different types of colloids, their dispersed phase, dispersing medium, and example. So first, aerosol. Dispersed phase is your liquid, dispersing medium is gas. Example, fog, clouds, mist. And another aerosol that is dispersed phase is your solid, dispersing medium is gas. Example, smoke, automobile exhaust. And then foam. Dispersed phase is gas, dispersing medium is liquid. An example is shaving cream. And emulsion, dispersed phase is your liquid, dispersing medium is also liquid. Example is milk, face cream. Milk is the best example of emulsion. Then sol, dispersed phase is solid, dispersing medium is liquid. Example, milk of magnesia and mud. Then foam, dispersed phase is gas, dispersing medium is solid. Example, foam, rubber, sponge, and pumice. Then gel, dispersed phase is liquid, dispersing medium is solid. An example are jelly, cheese, and butter. And solid sol, here dispersed phase is solid, dispersing medium is also solid. And examples are colored gemstone, milky glass. We will discuss more about emulsion after some time. Okay, then write the principle of centrifugation and its applications. So centrifugation works based on the principle that the denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. So applications, it is used in diagnostic laboratories for blood and urine test. It is used in dairies and home to separate butter from cream. It is also used in washing machines to squeeze out water from wet clothes. This is the method of centrifugation. Here, the denser particles are forced to the bottom and lighter particles are moved to the top when you spoon rapidly. Then how can we separate a mixture of two immiscible liquid? Immiscible liquid means the liquids which cannot be mixed properly, right? So a mixture of two immiscible liquids can be separated using a separating funnel, like what we call, yes, mixture of oil and water, we can separate them by using separating funnel. The principle is that immiscible liquids separate out in layers depending on their densities. So they will be arranged according to their density. Then applications: to separate mixtures of oil and water, we can use separating funnel. In the excretion of iron from its ore, the lighter slag is removed from the top by this method to leave the molten iron at the bottom in this funnel. So because the density of molten iron is more than the density of lighter slag, so lighter slag will be uh, moved to the top, and your what you call molten iron will be moved to the bottom. Then we can easily separate them. How can we separate a mixture of salt and camphor? You know, camphor is a volatile substance. So camphor changes directly from solid to gaseous state on heating. So here we use sublimation to separate such mixtures that contain a sublimable volatile component from a non-sublimable impurity. Here camphor is a what we call volatile substance. So if you heat, then it will evaporate. It will become gaseous. Then after you can cool it and make it again liquid, and then after solid. Some examples of solid which sublime are ammonium chloride, naphthalene, anthracene. These are the some examples of volatile substance which sublime. Sublime means they directly converted into gaseous state. Then what is chromatography? Right, its applications. Chromatography is the technique used for separation of solutes that dissolve in the same solvent. Application: to separate colors in a dye, pigments from natural colors, drugs from blood, we use a chromatography method. In which case fractional distillation is used. To separate a mixture of two or more miscible liquids. Miscible liquids means the liquids which can be intermixed properly, for which the difference in boiling point is less than 25 Kelvin, fractional distillation process is used. The boiling point, the difference in boiling points must be less than 25 Kelvin. For example, the separation of different gases from air, different fractions from petroleum product, we can use a fractional distillation method. What is difference between the apparatus of distillation and fractional distillation? Only a simple difference is there, that is, a simple fractionating column is a tube packed with glass beads. The beads provide surface for the vapors to cool and condense repeatedly. So the apparatus of fractional distillation is similar to that of simple distillation. The only difference is that a fractionating column is fitted in between the distillation flux and the condenser, because that will provide surface for the vapors to cool and condense repeatedly. Then how can we obtain different gases from air? You know, air is a homogeneous mixture and can be separated into its components by fractional distillation. So first we have to take air, then we will compress it and cool by increasing pressure and decreasing temperature, then it will become liquid air. Then now we will allow to warm up slowly in fractional distillation column. Now gases get separated at different heights because their boiling points are different. You know, boiling point of oxygen, argon and nitrogen are different, so they will be separated automatically. Now what is crystallization? How crystallization is better than simple evaporation? Right, applications of crystallization. Crystallization is a process that separates a pure solid in the form of its crystals from a solution. That's why the name of the process is called crystallization, because here we will get the crystals of solid, the solute, okay, solute in as a crystal form. Now crystallization is better than simple evaporation because some solids decompose, or some, like sugar, may get charred on heating to dryness. Some impurities may remain dissolved in the solution even after filtration. On evaporation, these contaminate the solid. So we have to follow crystallization method. It will be better than simple evaporation. Then applications of crystallization: purification of salt that we get from seawater, then separation of crystals of a alum, that is Fitzgerald, from impure samples. In this case we use a crystallization method. Here we will get the solutes in the form of crystals. Now what are the physical properties of matter? You know, the properties that can be observed and specified, like color, hardness, rigidity, fluidity, density, melting point, boiling point. These are called physical properties that can be observed. Now what is a chemical change? Give examples. Chemical change brings change in the chemical properties of matter, and here new substances are formed. So it is called a chemical reaction. Usually in a chemical reaction, what happens? The chemical composition changes and new substances are formed. Example: burning of a candle, roasting of iron. Okay. Then what are elements? What are different types of matters? An element is a basic form of matter that cannot be broken down into simpler substances by chemical reactions. Elements can be divided into metals, non-metals and metalloids. Now We will discuss about them more in the next video, the next chapters. Then write properties of metals and non-metals. So properties of metals. Metals have luster, sign. Here printing mistake is there. It will be your properties of metals. Okay. So metals have luster. That means they shine. They have a silvery gray or golden yellow color. They conduct heat and electricity. They are good conductor of heat and electricity. They are ductile. Ductile means can be drawn into wires. They are malleable. Malleable means can be hammered into thin sheets. Okay, we can make thin sheets by hammering them. Then they are sonorous. Sonorous means we can make ringing sound when we hit them. Okay. Properties of non-metals. Non-metal display variety of colors. Then they are poor conductors of heat and electricity. They are not lustrous. They are not sonorous. They are not ductile. They are not malleable. If you hammer or what we call, if you want to try to make wire using non-metal, then they will break. They are also not sonorous. They will not make sound like what we call metals. Now, what are metalloids? Give examples. Some elements have intermediate properties between those metals and non-metals. They are called metalloids. So there are some materials, some elements which show the properties in between those of metals and non-metals. That means they show some properties of metals and some properties of non-metals. They are called metalloids. They show some properties of metals and some properties of non-metals. Example, boron, silicon, germanium. These are the examples of metalloids. What are compounds? A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. In case of mixture, there is no fixed composition, fixed proportion. Okay, they have variable composition, and they also show the property of all the components. But in case of compound, there is fixed proportion, and compound does not show the property of all the components. Okay, because here in case of chemical reaction, the chemical what we call composition changes. So new substances formed. So compound is found in chemical reaction. So compound does not show the property of all the what we call components, but mixture shows the properties of all the components. And also compounds have fixed proportion, but in case of mixture, they don't have fixed composition. They have variable composition. Now, examples of compounds are water and salt. Now differentiate between mixtures and compounds. So elements or compounds just mix together to form a mixture and no new compound is formed. Elements react to form new compounds. In case of compound, a mixture has a variable composition. The composition of each new substance is always fixed. So in case of compound, the what we call compound, they have what we call fixed composition, fixed proportion. But in case of mixture, they don't have fixed composition, they have variable composition. And mixture shows the properties of the constituent substances, but compound does not show the properties of its constituents, its components. The constituents can be, in case of mixture, the constituents can be separated by easily following physical methods. But in case of compounds, we have to follow chemical methods. We cannot what we call separate the components using a physical method. Now we will discuss about emulsions. So what are emulsions? Emulsions are liquid colloidal systems in which there is a dispersion of finely divided liquid droplets in another liquid. They can be broken down into constituent liquids by heating, cooling, or centrifugation. So best example of emulsion is milk. Here, so these are the liquid colloidal systems. These are colloidal systems having liquids. Then milk, butter, cream, these are the examples of your emulsions. So these are also one kind of what we call colloidal solutions. Okay, so I hope you have better understood the chapter. If you have not watched the what we call PPT video summary of the lesson, then you can go to the description. You can find the link to watch the video. And here we have discussed three types of question answers. First, in-text question answers, then exercise question answers, and then self-created question answers. I hope you understood chapter very well. So wish you all the best. Keep learning, keep growing. Thank you.